Now we will go for the second example. So here, what is our V? That is domain of the linear transformation, that is M2 of R. And what is our W? That is codomain, that is R3. So what is our 0 of the domain over here? 0, 0, 0, 0. It is a 2 by 2 0 matrix. Next, what is our 0 of the codomain? 0 of the codomain is somewhat like this. Okay. Now, first of all, we'll find kernel and then we'll go for image. So let us recall the definition of kernel. You already know it till now. So it is, so which is further equal to, now what notation for V you are going to use here? This one, right? As I have explained you in the last example. So it is a collection of A, B, C, D belonging to M2 of R, that is our V, such that T of this is the notation that you have used for small v. So same thing will appear here. So T of A, B, C, D is equal to, and what is your 0 of W? That is 0, 0, 0. So which is further equal to, set of all A, B, C, D. Now I will not write this M2 of R. From the context, it is understood that it is an element of M2 of R. Now how is your map defined? In this way. So I will use it here. So it is A, B plus C, comma D is equal to 0, 0, 0. So again, which is further equal to, it is a collection of elements of the type ABCD, means a matrix ABCD, such that, now simply compare, A is equal to 0, B plus C is equal to 0, and what, D is equal to 0. Now again over here, this is one system. So A is equal to 0, next is B plus C is equal to 0, and the last equation is D is equal to 0. So we have to solve this homogeneous system again. So over here, our number of equations are 3 and our number of unknowns are 4, ABCD, right? So what will be our augmented matrix? 1, 0, 0, 0. Next is 0, 1, 1, 0, and the next one is 0, 0, 0, 1, such that, not such that, it is a constant matrix, right? Matrix of constants. So what is the rank in this case? So rank is 3 because it is already in echelon form. But how many unknowns are there? 4 unknowns, right? So number of parameters that we are going to use, that will be 1 again. But we cannot use parameter for D, since value of D is equal to 0. We cannot use parameter for A also because its value is 0. So parameter either should be used for B or C. So we will use the parameter for C. So once we use the parameter for C, what we are going to get here? So I will put C is equal to T. T belongs to what? R. So what will be our B? Our B will be what? Minus T. Right? So let us use it over here. So this is further equal to collection of, my A is already 0, my value of B is minus T, my value of C is T, my value of D is 0, such that T belongs to R. So which is further equal to, you can take that T out, so it is 0, minus 1, 1, 0, such that T belongs to R. So this is your image of, no, what is it? Kernel of T. So this is your kernel of T. Now let us go to find image of T. So we know what is our image of T? Our image of T is set of all T of V belonging to W such that this V belongs to what? V, right? Now whatever notation we are going to use here for this small v, okay, that comes from where? From here, right? So if such notation is not there in the example, then we have to introduce this notation, okay? So that kind of example also we will see, right? So this is equal to, T of which notation for V? Yes, you are right, A B C D, such that just a minute, it belongs to what is our W? That is R3, such that our V is A B C D belonging to, and capital V is what? M2 of R, right? So which is further equal to, now how is our T defined? T of ABCD is nothing but A, B plus C and D, right? So A, B plus C and D. Now I will not write this belonging to R3 because from the context it is clear that it belongs to what? R3 only, such that now you can see how many variables are visible, 1, 2, 3 and 4. So I will write here such that this A, B, C and D belongs to what? R. So this is further equal to, now you can take that A out. Now in the first coordinate coefficient of A is 1, but in the second coordinate A is absent, so it is 0, right? Similarly for the third coordinate, plus B. Now in the first coordinate B is absent, so coefficient is 0. In the second coordinate it is 1, and in the third coordinate B is absent, so it is 0, plus C. In the first coordinate C is absent, in the second coordinate it is present, so 1, the third coordinate is absent, so 0, plus D, absent, absent, present, right? Such that this A, B, C, D belongs to what? R. So which is further equal to, now note one thing again, if you observe this second term and third term, you can see one point to be common, and which is that point? 0, 1, 0. So that can be taken out, right? So therefore this is equal to set of all A 1, 0, 0 plus this B plus C in one bracket, and the point is 0, 1, 0 which we have taken common, plus D 0, 0, 1, such that this A, B, C and D belongs to what? R. Now again similar logic, now since B and C are real numbers, so this B plus C is also a real number. I will call it as some B dash, so it is a collection of A 1, 0, 0 plus B dash 0, 1, 0 plus D 0, 0, 1, such that this A, B dash and what? D belongs to what? R. So this is regarding image of